Hello sir, my name is Mohammed Hassan. I am explaining Atc Assignment topic design and implement a lexical analyzer and parser that verifies whether a mini ATC program is grammatically correct using the provided context grammar for mini ATC language. Next slide. Introduction. Automata theory is important concept in compiler design, lexical analysis and syntax analysis are major phases of a compiler. In this project, we implemented a lexical analyzer and parser for mini-ETC language to check whether a program follows the grammar rules correctly. Problem statement design. The aim of this project is to design and implement a lexical analyzer and parser for the mini-ETC language. The lexical analysis analyzer identifies tokens such as keywords, identifiers, numbers, operators, and delimiters. The parser verifies whether the given program is grammatically correct according to the CGF rule. The main objectives of this project are to develop a lexical analyzer for mini-ATC, to design to identify different types of tokens, to implement a CGF-based parser, to verify program syntax correctness, to understand the practical application of automata theory. Mini-ATC is a simple programming language. A program starts with begin and ends with end. It supports direction statements, assignment statements, and the print statements. Next, lexical elements. Lexical elements are the basic building blocks of the language. Keywords are reversed words such as begin, end, int, and print identifiers are variable names that start with letters, numbers, and non-negative integers. DFA for numbers. DFA is used for number recognition. If the input contains only digits, it moves to the accept state. If the invalid character appears, it moves to the dead state. Example like 20, 10, 250, and 99 are valid numbers. Lexical analyzer. The lexical analyzer reads the input characters by character. It removes spaces and add new lines, identifies tokens, classifies them into categories, and send them into the parser. Context-free grammar. Context-free grammar defines the syntax rules of the language program. The program structure is represented by using grammar productions. Rules for statements, expression, and operators are defined in this CGF. First program runs, then begin with a statement list and end. Statement list start, statement list or epsilon like this. Implementation. The implementation includes into major components like input buffer, token matching functions, lexical analyzer, parser functions, grammar validation. Important functions are used to recognize like keywords, identifiers, numbers, and expressions. Recursive descent parser. Recursive descent parser is a top-down parsing technique. Each grammar rule is converted into a function. These functions call each other recursively to validate the system syntax. It is simple to implement and suitable for small programming languages. The expected outcome of this project is that the system should correctly identify tokens and verify whether the mini etc program follows the CGF rules. Conclusion. This project successfully demonstrated lexical analysis and parsing. Automata theory components are applied practically. The parser validates mini etc program using CGF rules and improve understanding of compiler design concepts. References used for this project includes Automata theory textbooks, compiler design notes, mini ATC assignment specification, and classroom notes. Thank you, sir.